Okay, guys, so in this video, I want to introduce measures of relative standing. Basically, why do we need measures of relative standing? When we want to compare two values from absolutely different distributions, and maybe distributions that even have different measuring units. How to do that? Measures of relative standing will help us in that avenue. So for example, I just wanted to give you an example. I'm making it up on the fly. So let's say you are a biologist studying whales, and you come up and you're observing a whale that weighs, I don't know, 3 tons. And then also, is it a big whale or is it a small whale? And then uh, you have a guppy fish, which is, let's say, 1 inch long. Is it a big guppy fish or is it a small guppy fish for, you know, the guppy size? So, and how do we compare like that 3-ton whale to this guppy fish that's 1 inch long? Or like, which one of them is bigger in their population? So basically, measures of relative standing help us to compare apples and pears. Let's explore this topic a little bit more so you got a feel of why it is important. I want to ask you, let's say I have a friend and who is taking biology and physics this semester, and she told me that she got a score of 40 on her biology exam and a score of 90 on her physics exam. So which score do you think is better? And I want you to pause here and to think about this question a little bit. What do you think is better? Also, if you said that you cannot compare those two scores, which information would you need to answer the question be more informed about the situation? So pause here and think about answers to those questions. All right, so a lot of students here say, well, we want to know what the maximum number of points was, and just in case if these are not percentages and just raw points, which, yeah, that's what they are. And some say after a while, they say, okay, we also want to know the average. If the exam, let's say exam is graded based on the curve, what's the average score? Did I do better than the average or not? Okay, so here I give you some the average scores for each exam, and that is helping a little bit. Like you could tell that she did better in better than the average in both of the classes, but is it a complete information? In order, okay, so yeah, if one was below the average and one was above the average, then that's clear. The one above the average would be better score. But now for these two, both of them are above the average. So in which class did she actually get a better grade? Okay, so we need a little bit more information again. So what kind of information would you want to know? Tell me right now. Which information do you need to know in order to answer that question? All right, so hopefully you already answered that question. And in order to aid in answering the question, I have two examples of these two distributions. Okay, so let's say these are my scores for one exam in one class, and these are the scores for the exam one in a different class. Let's pretend that. So the in both exams, the average was 70, and you see how this distribution of scores is not normal. It's like it's all over the place. So let's say we have three standard deviations, right? One, two, and three. So let's say that I'm one standard deviation away. Well, that's about I'm at 75%, right? 75% of all in the entire class. Now, if I go two standard deviations away, but then it's even more. But uh, what if for this distribution, um, do you see how these one standard deviation, two standard deviations, I mean, they cut out different percentages? Yeah. So, but anyway, the distance from the center, from the average, is very important because it tells you what percentage of the class scores are above you and what percentage are below you. So we need that standard deviation. Okay, so now the question is, I give you a standard deviation. So for the biology exam, it was 5. For the physics exam, it was 7. All right, that's good. So we need to figure out how many standard deviations is it away from the average score. How many standard deviations your score is above the average score? How do we figure that out? Okay, so in case of 30 versus 40, it's easy. Our standard deviation is 5. So 40 is 30 plus 5 twice. So for this score, the standard deviation, S1, is 2. Okay, how do we figure out the standard deviation for this score, 90 versus 80? Okay, the standard deviation is 7. So 80 plus 7 is 87. That's one standard deviation above 80. And then if you add 7 again, you get 94. So we don't land on 90. So 90 is somewhere between 1 and 2 standard deviations. Well, that already is enough information to say that that score 40 is better because the standard deviation is 2, and here's between 1 and 2, so it's below 2. So this score is not as good actually as the score in the biology exam, you see, because it's not far away from the average score as 40. 40 is further away from the average score than 90 is. Okay, so but how do we calculate that distance from the average in terms of a standard deviation? Well, turns out we have a formula. So we find the distance between the actual distance between 90 and 80. So we have x minus the mean, and now we divide this distance by the unit step, by the standard deviation. So for this score, we're going to have 90 minus 80 divided by 7. And the value that I got was 1.42857. I'm gonna, and some more decimals, but I'm gonna round this value to 2 decimal places. So it's gonna be 1.4, and then I'm gonna round 2 up because the following digit is 8. So it's gonna be 3, 1.43. So this uh, this score is 2 standard deviations above the average, and score of 90 is only 1.43 standard deviations above the average. So this score of 40 is better than the score of 90. Um, so let's talk about the formula. The number of standard deviations above or below the average is called a z-score. Okay, it's a z-score. For short, we're just gonna call it z. And the formula is x minus the mean, our value raw score, minus the average score, divided by the standard deviation. Okay, so these are z1 and z2. So that's for the sample. For the population, the score, the formula is the same. We just use a different notation, right? The mean of the population mu and the standard deviation of the population sigma. Okay, so these are your z-score formulas, and you need to remember them. They're very important. You'll be using them a lot. So that's how we compare apples and oranges. One more thing on the z scores. So when you have your normal distribution, the center, the mean, has a z-score of 0. And when you go to above the mean, z-scores are positive. Positive going in this direction, and if you go in the other direction below this the mean, then well, that's mean, z-score is 0, yes, the z-scores are negative. Okay, so if you get a negative z-score, you automatically know that the value is below the mean. And if you go above, if the z-score is positive, then you know you're above the average. And to illustrate this idea, this is the picture that you already seen before. We have a mean here, which would be an actual number, let's say for the IQ scores, that would be 100, and then which corresponds to a z-score of 0. So I want you to think of z-score as the distance from the center, from the mean, in terms of standard deviations. Okay, so here, if we move to the left, the standard deviation, the z-score becomes negative because we're moving below the mean. And on this side, the z-scores are positive because we're moving above the mean. Now, here you're going to have sort of like two different scales of measurement, okay? So these are going to be actual values. Let's say when we were talking about our IQ scores, the mean was 100, and the standard deviation, I think, was 15. So this value would be 115, and that's the z-score is 1, because that's 1 standard deviation up. Okay, the next value here would be 130, okay, and the z-score is 2 because it's 2 standard deviations up. So do you see how there's actually two different scales. One is the actual value, and another one is a z-score of that actual value. And that's important. I wanted to bring it up right now because in the future, we're going to be converting between these two scales back and forth. Okay, so that's what's coming. But for now, I want you to answer this question. 3 students take equivalent stress test, which is the highest relative score. A score of 144 on a test with a mean of 128 and standard deviation of 34, or a score of 90 on a test with a mean of 86 and a standard deviation of 18. Or maybe a score of 18 on a test with a mean of 15 and a standard deviation of 5. So I want you to think about this question and give me the answer.